This is Chemistry Podcast 1.8. We're going to talk about dimensional analysis. So dimensional analysis is just a method that we're going to use to convert units. We're going to use it all year long in chemistry, and it uses what we call conversion factors. So here are some examples of what conversion factors are. They're just numbers that are in different units, so values that are in different units. For example, 1 foot is 12 inches. There are 2.54 centimeters in an inch, or 1 mile is 1.6 kilometers. All of these values have the same numerical meaning, we just use different units with them. So things that you need to know, keys for the dimensional analysis. What we try to do is we're going to set up a problem that's in a table like this, and we're going to try and get the units to cancel. So I'll show you how to do a couple examples with these. But just like in math with fractions, the units can cancel if they are on both the top and the bottom of the setup. If I can get grams up here and grams down here, they'll go away and cancel just like in math. So things on the top and the bottom will cancel. When you go to solve this, you're going to multiply all the numbers on top and divide by everything on the bottom. Alright, we can set up conversion factors using the metric slider that we talked about the other day. And remember, this is the King Henry died by drinking chocolate milk. This is the base unit. What you're going to do, for example, if I want to know millimeters and centimeters, what's a conversion factor? You look for the biggest unit first. So if I look at a centimeter and a millimeter, I know that the centimeter is larger, because remember, these are the large units, and these are the small units. So whoever is the biggest gets a 1. In this case, the centimeter is bigger than the millimeter, so I'm going to give it a 1. And then to figure out how many millimeters are in a centimeter, you count the jumps. There's going to be a 1, and then we have to figure out how many zeros go after it. So since there's only one jump between a centimeter and a millimeter, that means that there's 10 millimeters in 1 centimeter. Let's do this again. If I have liters, liters is a base unit, millimeters is down here. A base unit compared to the millimeter, the base unit liter is going to be bigger. And then to figure out how many zeros to put behind this 1, 2, 3 jumps, 1, 2, 3 zeros. We can do it again. Kilograms and milligrams. Kilograms are way up here, milligrams way down here. Kilogram is the largest, it gets a 1. And then to figure out how many zeros go behind this, we count the jumps. So there's 1, 2, 3, 4, 5, 6. That means I put 6 zeros here, and that tells me that there are 1,000,000 milligrams in 1 kilogram. And then for the last one, I have a meter and a kilometer. So the meter, remember, is not here. This would be a millimeter. A meter is a base unit. So I have my base unit and my kilometer. The kilometer is the biggest, it gets the 1. And then to figure out how many zeros go behind this, we count the jumps. 1, 2, 3. So 1, 2, 3. There are 1,000 meters in 1 kilometer. You need to make sure you can do these pretty quickly because we're going to use them in the upcoming problems. So we're going to do 4 example problems together. Here's the first one. 40 miles is equal to how many feet? They've given me a conversion factor here, and you guys are going to have a sheet, or I will give you the conversion factor. If it's going from the metric system to, I guess you could call it what we use in the United States, the English system. So I'm going to always start with what's given, which is the 40 miles in the problem. And I write it out. Don't forget to write in units. I'm going to build my table. Alright, here's the conversion factor. Once I get my starting value here, there's nothing under here. We can think of it as a 1. If I go over here, 5,280 feet in 1 mile. We said that if you have the same unit on the top and the bottom, it'll cancel. So that means I want to put the 1 mile on the bottom. And I'm going to put the 5,280 feet on top. What that allows me to do is my miles are going to go away. I'm left with feet. And that's what they're asking me for. That's the only unit that's not crossed out. And then I have to do the math. 40 times 5,280 gives you that many feet. So if you don't have your calculator, you should go get it, and you should be doing these with me. All right, and that's a pretty big number, so we should probably write it in scientific notation. So I would say 2.11 times 10 to the 2, 3, 4, 5th feet. So that's how you do these. If I do another, we have 300 meters is equal to how many inches? I always start with what was given, which is the 300 meters. All right, they tell me in here that there's 2.54 centimeters in an inch. I can't put the 2.54 centimeters here because it won't cancel with my meters. That means I need to come up with the conversion factor that will get me to centimeters, and then I can use this. So I'm going to think back to what we were just talking about. And a meter is a base unit, and we're dealing with centimeters in the conversion factor. So the base unit is the biggest unit, and that's 1 meter. And then your centimeters would need 2 zeros because there's 2 jumps. So that would be 100 centimeters in a meter. And I'm going to plug that in here. I would put the 1 meter on the bottom, so it cancels with this. I'm going to put the 100 centimeters on top. My meter and my meter go away. Now I'm in centimeters. Well, now I can use this because this has centimeters as well. So I'm going to take the 2.54 centimeters and put it on the bottom. And the 1 inch is going to go on top. So my centimeter and my centimeter go away. I'm left in inches, which is what they asked me for. So I'm finished with the setup of my problem. All you have to do is plug that into the calculator. And if you do that, you should end up with 11,811 inches. And again, that's a pretty big number, so I'm going to convert it into scientific notation. Times 10 to the 4th inches. And that would be your final answer. So make sure when you're using these that your units end up on the top and the bottom so that they can cancel. All right, we're going to try 2 more. This one is 64,000 kilograms is how many tons? So I start with what's given, the 64,000 kilograms. Set up my table. This time they've given me 2 conversion factors. I'm in kilograms. If I look at what I have pounds, I have grams, I have pounds, I have tons. Well, I can use grams because, again, the King Henry died by drinking chocolate milk. I can make up a conversion factor that will help me go from kilograms to grams, so that I can use this first and this one second. So, kilogram is here. A gram is a base unit. The kilogram is bigger. 1 kilogram equals how many grams? 1, 2, 3. 1, 2, 3. There's my very first conversion factor. So since I'm in kilograms, I'm going to put the 1 kilogram from here on the bottom, and the 1,000 grams is going to go on top. That's going to get my kilograms to cancel. Then to get my grams to cancel, I can use the first one that we talked about right here. I want the 500 or the 454 grams to go on the bottom and the 1 pound to go on top. I do it that way so that my grams and my grams go away. And now I'm in pounds. I can use the second conversion factor because this has pounds to tons and they're asking me for tons. So the 2,000 pounds goes on the bottom and the 1 ton goes on top. That gets my pounds and pounds to cancel, leaving tons as my only unit that's not crossed out. So all I have to do is plug this into your calculator. Now when you're plugging this in, it'll be 64,000 times 1,000 times 1 times 1, so I'm not going to do those. And then we have to divide by everything on the bottom. So 454 divided by 2,000. You need to put that divided sign in front of everything that's on the bottom. So that's what it should look like when you punch it into your calculator. And if you do all of that, you're going to end up with 70.48 tons. And if I look at significant figures, I look back to the original number that we put in here. This number only has 2 significant figures, so I'm going to round my answer to 2, which is just going to be 70 tons. All right, last one, 2 years. And in this one, they didn't give me any conversion factors. I have to come up with them all on my own. But since we're talking about time, that shouldn't be a big deal. So the easiest thing maybe to break years down into is days. You could go to months, but then you'd have to go to weeks, and I think it's just easier if we jump from years to days. So we know that in 1 year, there are 365 days. But that will get me to days. So here, we'll put it here. 1 year, 365 days. My years go away, leaving me in days. Well, now I have to get from days to hours, which I know that in 1 day, there are 24 hours. So since I'm in days, my 1 day from my conversion factor needs to go on the bottom, because that way these two will cancel. And what I'm going to go into is the 24 hours on top. So that leaves years canceled out, days canceled out. Hours is the only one not canceled. So if I plug this in, I take 2 times 365 times 24, and all of that is going to leave you with 17,520 hours, which is a very big number again, so I'm going to convert into scientific notation, and I'm also going to look here for 3 significant figures. So I'm going to round this to 3 significant figures. So 1.75 times 10 to the 1, 2, 3, 4th hours. And that's your final answer. All right, so before class, what you need to do, you need to calculate how many seconds you have been alive. Start with your whole number, whatever your age is. If you're 17 years, start with 17 years. You don't have to count for months or anything like that. So calculate how many seconds you've been alive. Make sure when you do these setups, don't forget, you do a table like this, and you want the same units on the top and the bottom. Same units on top and bottom. That way that they cancel. All right, that's the end of podcast 1.8. We'll see you in class, and we'll talk about how many seconds you've been alive.